This week on the show, we show you a throwaway browser configuration on a FreeBSD with POT within 5 minutes. OmniOS as OpenBSD guest with Beehive as well. BSD versus Linux distro development comparison. My FreeBSD laptop builds for a ThinkPad X390. FreeBSD current binary upgrades are possible, and we describe you how in this week's episode of BSD Now. BSDNow episode 359, Throwaway Browser, recorded for the 15th of July 2020. This episode of BSDNow is brought to you by Tarsnap, the online backup for truly paranoids. Hi, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
Welcome to this week's episode. By the way, want to hear a joke? When's the best time to harvest cherries? When the neighbors are on holiday, of course. Moving into the headlines this week, the throwaway browser, the namesake of this episode, on FreeBSD with POT within 5 minutes. So the title alone is cool.
POT is a great and relatively new jail management tool. It offers a more DevOps-style provisioning and can even be used to provide Docker-like scalable cloud services together with Nomad, which is a cluster scheduler, and Consul. If you want to know more about that, they point you to actually the FreeBSD Papers website. Luca Pizzamiglio had a paper or a talk he gave at FOSDEM, orchestrating jails with Nomad and POT. So when using FreeBSD on your desktop, you can also make use of this to make a throwaway browser jail. That way, the browser environment is reliable and completely erased and reset each time you create it with this single command. Note below that all these POT commands need to be run as root. So first you want to install and set up POT as described on the POT website. You can just package install POT and then do POT init. And then in this case, they're setting the attributes no RC script and also making it not a persistent jail, so it won't be started again if it closes and so on. And then set up a browser flavor that basically changes the package repo to use the latest repo instead of the quarterly repo, bootstraps package, disables sendmail, enables SSH, creates a Firefox user, and then installs Firefox. They can just do POT create a new jail called one-time browser, install FreeBSD 12.1 on the public network bridge, and use the flavor the flavor browser. And then it will use that flavor file you just created and install Firefox. Mm-hmm. Then you can just POT start one-time browser and then use SSH with X forwarding, and then suddenly the Firefox running in that jail will appear on your desktop. And then you can use it, and then you, importantly, can throw it away. So you just POT stop one-time browser, and then destroy one-time browser, and now it's gone. Or even better, you can snapshot it before you use it, or after you've, done just the basic setup you want to get the buttons where you want them or whatever. You snapshot it, and then you can do your browsing, and then POT revert to roll back to the older version of the snapshot, and that way any tracking cookies or anything that gets recorded, any kind of history that gets recorded by the browser gets erased every time you revert to that snapshot of a known good, clean version of the browser.
Mm-hmm. Nothing accepted cookies or any other backdoor thingies in there. It's nicely tucked away in the jail.
You get a nice, clean version every time.
Like fresh install. Cool. That's pretty straightforward so far. And could be used for any other kind of applications that could also be an X11 thing, like not just a browser, but any other application that runs in a separate environment or should be run there. Cool. Very straightforward. People should use this more often. And thanks for the write-up. Then we have OpenBSD guest with Beehive on OmniOS. Yeah, so they describe on PB Digital that today they will be creating an OpenBSD guest via Beehive on OmniOS. They will be adding a pass-through Ethernet controller, so they can have a multi-home guest that will serve as a firewall and router. This post will cover setting up Beehive on OmniOS, so it will also be a good introduction to Beehive itself. As well, they look into OpenBSD's UEFI bootloaders, so if you have trouble with this, there are also some insights there. So of course, first things first, install Beehive, otherwise it's not very entertaining. They will cover the installation of Beehive onto an OmniOS system briefly. They have a separate link in the show notes or in the article they wrote to setting up the OpenBSD boot disk, if you want to jump ahead to that. To install Beehive onto OmniOS, it's fairly straightforward. Package install brand/Beehive. This will install system/Beehive, so simple. Then they create a storage for the OmniOS zone guests. Every zone on a system has at least one dedicated ZFS dataset, and it's good practice to create a parent dataset under where all zones will live. Common convention is to mount this dataset as /zones and create it at the top level of a pool. So they do a zpool create data. In this case, the disk is called C2T1D0, but your mileage may vary. That's fine.
Well, yes. That's how disks are named on Solaris. So instead of ADA0 or DA7 like we have on FreeBSD, they have these names, which means controller 2, target 1, disk 0.
Mm-hmm. Yeah, so you can.
So it also tells you kind of where on the bus the disk is.
Yeah, if you're used to that convention, then it's fairly straightforward. Then you can verify this with a zpool list. Yes, the pool appears. Excellent. And it has the size that you intend to have. Now that this pool exists, the following command will create the top-level ZFS dataset named zones. Do a ZFS create -o mount point equals /zones to the data/zones. Okay. The creation of the ZFS dataset can be verified as well using ZFS list. This is not too exciting, but it should appear there, otherwise something went wrong. Then you set up the OpenBSD boot disk using the miniroot67.fs disk image, download it from OpenBSD CDN, and create a block device to boot from, which is lofi adm-a /zone/iso/miniroot67.fs to dev lofi/1. Then you create a VNIC, a virtual network interface card, using dladmin or dladm. Create -vnic-le1000g0 to OpenBSD 0. Then you configure that NIC to see that it has a link. Yes, that is routing packages. Then you configure the physical network card for PCI pass-through, which you then make work using prtconf. Following a couple more steps that are all documented pretty well. And then you go to configuring the OpenBSD Beehive zone. That takes a couple of commands in zone config. And once that is set up, you install the OpenBSD Beehive zone, boot the OpenBSD Beehive zone, and then go to the console to log in. Set a console in the OpenBSD Beehive zone and boot that to the root disk with UEFI. Yeah, so that's a nice tutorial, and all the way down to where you want to be. You find you can do a zlogin-C OpenBSD or SSH into your target machine, and that pretty much confirms that this machine has network using the PCI pass-through. Very nice. So, time for the news roundup this week. We have a BSD versus Linux distribution development article over on DistroWatch.
BSD versus Linux, and they say comparing apples to BSD has written in and asked. I was reading one of the old articles from the DistroWatch archives, and one of the things mentioned was how the BSDs have a distinct approach in terms of packaging the base system relative to the userland apps, and that Linux distros at the time were not following the same practice. Are there Linux distros that have adopted the same approach in modern times? If not, are there technical limitations that are preventing them from doing so, such as some distros supporting multiple kernel versions maybe? And so DistroWatch answers. In the article mentioned above, I made the observation that Linux distributions tend to take one of two approaches when it comes to packaging software. Generally, a Linux distribution will either offer a rolling release where virtually all the packages are regularly updated to the latest stable branch, or a fixed release where almost all packages are kept at a set version number and only receive bug fixes for a long lifecycle. So projects like Arch and Void Linux are rolling releases, and options like Fedora and Ubuntu offer more of a fixed platform, which is funny because I consider Fedora to be a lot more up-to-date than CentOS, but I guess they're mostly talking about desktops here. Anyway,
could be.
Basically, with few exceptions, Linux distributions all fall into one of those two categories, where there's a rolling release of constantly changing everything, or a fixed release where most things stay still. The BSDs, in contrast, tend to take an alternative approach. Operating systems like FreeBSD and OpenBSD provide a fixed core or base operating system. The base tends to be small, stable, and only change in small evolutions on a set schedule. OpenBSD is every 6 months. FreeBSD's major release every 2-ish years and a minor one supposed to be every 6 months or whatever. The cores of the main BSD branches are fixed. Meanwhile, most applications which you install on the BSDs, whether those are LibreOffice, Firefox, your desktop environment, or whatever, are kept up to date with their upstream versions via the ports and packages system. Base operating system is fixed and stable, while the applications the user runs can be kept up to date with the latest and greatest. This allows the BSDs to offer close to cutting edge applications, but without the risk of a routine update breaking the core operating system. A big part of why the BSDs have this stable core and separate third-party software applications, while Linux distributions tend to take an all or nothing approach to these version upgrades, is the BSDs are develop all the core operating system components as part of one large project. The FreeBSD project's repository contains the kernel, the command line tools, the file systems, all the base libraries, and that is all one repo managed by one set of developers. And then third-party applications, which we call ports and packages, are software developed by other people that just happens to work on FreeBSD. So in other words, FreeBSD is a whole operating system, and then you can run lots of software on it. Kind of like if you compare that to Windows or Mac OS, right? FreeBSD is the bits you get with the operating system, and then you have something like the App Store that allows you to install software written by other people, or sometimes by the people from the operating system, but it's the software that's not included. What's really interesting is FreeBSD has gone and split that even further, where we have 2 package repos. One that's updated quarterly and only gets frequent security updates, whereas there's the latest one that is basically always the latest versions of the software. So depending what you're after, you can get a little bit more of that rolling release or of the fixed release, but on a quarterly basis and separate.
Yep, depends on your needs and speed of updates that are required, but security updates should never be delayed.
Linux distributions, on the other hand, are different, oftentimes because what makes that distribution is generally the combination of that third-party software. Right, like Linux, the operating system by itself is just a kernel, and then you have the GNU project where you get like glibc and like a lot of the command line tools, like the core utils and so on. But really, the difference between Debian and Slackware is not the kernel and that base software; it's what else is included, and that's why you don't see that kind of same split as much, because otherwise, the only difference between Debian and Slackware would mostly be which kernel version they happen to be giving you.
Yeah.
And there wouldn't be much of a compelling operating system there. And the fact that the Linux kernel is made by one team, the core utils and libraries are made by another team, the installers over here, and then the distro is just packaging a bunch of that together, and they add all these third-party apps together to actually make something interesting. While it's difficult, it's not entirely unheard of for some Linux distributions to attempt to maintain a small, stable core while regularly updating desktop applications. Some of these kind of semi-rolling release approaches taken by things like PC Linux OS or Chakra Linux, where the kernel, the low-level graphics libraries, the core tools tend to upgrade slowly, while the desktop applications are updated more frequently. And they can work for a while, but eventually those core components need to jump ahead, and you can end up having problems where the software needs to be compatible with the version of the core, and it can run into issues.
Yeah. But yeah, that's the distinction to make, or that are usually made. And there's probably more. Definitely check out the full article on DistroWatch and probably discuss it a little bit.
Yeah. And they just, in conclusion, they say, while there are technical hurdles such as distributed development that make it harder for Linux distributions to provide the same sort of base platform with third-party applications, it is possible for a Linux distribution to do. There are several solutions available, each with their strengths and weaknesses. None of these approaches is exactly the same as the BSDs, but some of them are similar and offer some of the same benefits.
Speaking of benefits, the next item might be of interest to the laptop builders out there, or for the people who are in the market for a new one. We have a FreeBSD Laptop Build for you over on the Cyberdyne Systems website, corrupted.io. They have written that they've always liked the ThinkPad hardware, and when they started to do more commuting, they decided they needed, commuting these days? Well, okay. They decided they needed something that has a decent sized screen, but fit well on a bus. Luckily, about this time, Lenovo gave a nice gift in the ThinkPad X390. It's basically the famous X2 XX series, but with a 13-inch screen and a smaller bezel. So with this laptop, they figured it was time to actually put the docs together or on how to get the FreeBSD workstation working. They have documented more in the future post or in another one for hardened BSD, but this one is for FreeBSD base, yeah, for BSD. And the hardware, for the people who don't know what this machine can do, 8th generation Intel Core i9, 1.9 gigahertz, 16 gigs of RAM. They replaced the 15 gigs NVMe disk with a 1 terabyte Samsung Evo Pro NVMe disk. Yeah, more space, excellent. They have a 13.3 inch 1920 by 1080 IPS display, Intel graphics, Intel Wireless 9560, AC 802.11 AC, and Bluetooth 5.0. All right. They have also, important parts that it now supports USB-C and charging from USB-C. So we probably need a couple of new cables, or a good hub for you. Okay, so let's get to the basic parts. What works? The wireless, keyboard, trackpad, track point, the backlight, sleep and resume, and sound. And they couldn't yet get working the microSD reader and Hibernate. Okay, so far so good. That's a decent machine you can put together this way. That does something already. They walk through the installer. That's pretty straightforward. What kind of options they selected, and some of the core packages that they installed after the installation is done. And then they have a couple of configuration settings. From my glance at them, they are not too system specific, so they could also be applied to other laptops of this kind. Yes, definitely disable the bell with current.vt.enable_bell equals 0 in sysctlconf. The comment there is the hardware bell is deafening. I don't frequently want it, so go away. Yeah. They set up PF with a very simple PF config to block a couple things, then set skip on LO0 and pass out keep state to do the traffic from inside to the outside world, not the other way around. Cool. The couple services also configured for, I guess, X11 use, and setting up of users, and some extra notes back down the list are the backlights. They need to add a new defd rule, and that's provided in user local share examples, Intel-backlight. So you just copy those to user local etc defd, and that should give you better backlight out of the box. And future Wi-Fi improvements are also coming down as well as USB audio devices. They have a section on that. So all in all, you can start with that laptop, your BSD, or continue your journey where you left off from the old device that you're migrating from. And who knows? Maybe we'll see some more Wi-Fi things coming down the line. I see a couple things have changed in Current recently. So maybe there is more support coming down the line. But yeah, the things that were working are pretty well for the things that you would expect from a laptop. And I don't see anything about, battery runtime or how long this thing will keep running with a decent workload. But yeah, so far so good. Expat.
I imagine it's somewhat similar to like my X270 but slightly better because it's newer.
Okay, that's our laptop shootout, or more like a setup. And let's talk about how you can upgrade your FreeBSD Current with binary upgrades. Ooh, that sounds cool.
Yeah, so this is a project to extend FreeBSD Update to handle updating stable and current branches, not just releases. I know Chris Moore tried this years ago, but ran into some issues with just the way it was working and decided to go a different direction. But in this case, somebody has actually wired up the FreeBSD update build process to make it work. So they say, disclaimer, this is a proof of concept and not an official FreeBSD project thing, but up.bsd.lv is a proof of concept for binary updates for FreeBSD's current and stable branches to facilitate more exhaustive testing of FreeBSD and the Beehive hypervisor, especially, Beehive is getting patches and they're only available in current, and people would like to be able to run current, but update it without having to recompile and so on. And, OpenZFS 2.0 is coming soon, and again, it'll be handy to have. So updates are based on the SVN revision of the official FreeBSD release engineering bi-monthly snapshots. So you must install from update or up.bsd.lv disk1 ISO install media to obtain updates due to the nature of FreeBSD update and to discourage use of this service on a production system. This update also requires the CA root NSS package, the certctl tool, or another certificate bundle to support the retrieval of the SSL certificates. But once you've done that, to perform an update, you can specify the destination snapshot with FreeBSD update upgrade-r 13.0-current- whatever revision number you want, and then FreeBSD update install, reboot, FreeBSD update install again, and then your package and ports are ready to be updated, and so on.
Mm-hmm. Yeah.
And so this doesn't work for minor updates. Basically, it treats every upgrade of current as if you were upgrading from, 11 to 12, not as if you were installing FreeBSD 11.1 patch 3.
Okay, it's always the major one.
Which I think might be how they got this to work where Chris Moore had failed previously.
Okay, but it's definitely a path out of your current. And yeah, why not? It's a way forward.
Yeah, the only thing that's a little bit cumbersome with it right now is you have to know what revision you want to update to. And basically, so you have to go to this website and find out which versions are available and update to them. But that can be overcome, and that is not that bad of a requirement at this point.
Yeah, that can be enhanced. But yeah, it's a start. It's a good start.
Oh, actually, they have a new command, FreeBSD update list updates, which lists the available versions. So problem solved.
Okay, pick and choose.
So yes, if you're interested in giving this a test, it's especially useful if you're going to have a machine where you're going to say test changes to Beehive and OpenZFS. And yes, special thanks to Connor Be for co-development this, and then obviously Colin Percival for creating FreeBSD update in the first place, and the FreeBSD release engineering team for helping to maintain the build infrastructure that makes it possible.
And last but not least, Scale Engine for providing the bandwidth.
Yes, we host the mirror out of the data center in Portland.
Okay. Yeah, see, that's a nice collaboration in various bits to bring this service to the people who are on current and want to get a newer current.
This week's episode of BSDNow is brought to you by Tarsnap, online backups for the truly paranoid. Head over to tarsnap.com/BSDNow and you can start backing up your data. Because you definitely need backups.
Mm-hmm.
As much as you think you might not, you're going to wish you did. And Tarsnap makes it really easy. It's just, you can put one line into a cron tab and you're good to go. And more importantly, because it's pay as you go, you put in some money and then you just use it until the money runs out and then you put in more money. It means you never get a surprise bill.
Yeah, it's very predictable.
Right? Because you can't use more money than you put into it. And so you can never get surprised. So just head over to tarsnap.com, try it out, start backing up your stuff, and you'll be able to sleep better at night.
Oh yeah, because no one else can get to your backup in like the background or hack the server where it's lying on or whatever, because it's encrypted and you're the only person who's holding the key. And before your files leave your computer, they get encrypted locally first and not encrypted on the cloud where it's already too late or on the way. People could snoop the actual files from the network. No, it's everything encrypted locally. You're holding the keys. You're holding everything that you need to decrypt everything. And as long as you have the keys, you can get your data back. No one else. There are various clients available for the Unix systems out there, as well as Cygwin on Windows. So that's even more of a reason to use Tarsnap, because saying, oh, I don't have a client for my system doesn't work on this one. It has pretty much all the systems under the sun.
And importantly, the client is open source. So you can look at it and validate it, and you could patch it to run on whatever weird operating system you happen to need to run it on.
You should also check out the Tarsnap documentation. There's a Tarsnap IRC channel on FNet if you have questions. There's probably, there's a mailing list for Tarsnap users, so you can exchange your latest backup statistics or any questions you might have there. Or you can contact also the author directly and ask question if that is very specific to your use case, for example.
Yes, and then they even have a great technical section on their website, like, why are TarSnap prices defined in pico dollars?
That's a bit unusual for pricing, but it works.
Because rounding and money don't work well together.
Turns out it does, yeah. And the diagram down the page, on the front page, checks all the boxes and describes how all this thing is working in the background and how it's leaving your computer in encrypted form or going back down in the other way with the keys to the castle. All right, feedback and questions are always the part of the show that not only our listeners look forward to, but also us, because it's very unscheduled, or let's say unprepared, because we usually don't know what's coming. And if you don't keep us with supplying your questions, then this section will be very empty, and we will be very sad because we don't have anything to answer. Feedback at BSDNow.tv is your email address where you can send all these in, and in future episodes they will appear, and we will hopefully answer your question or the issue that you might have. The first one is Carl this week with pfSense. Carl writes, "Hi Alan, Benedict, and JT. I started listening to your show a few years ago and really enjoy a new dose of BSD whenever an episode comes out." Yep, same for us. I have pfSense running on a small fanless box as my home firewall and router. I have a second box with identical hardware, which I'd like to maintain as a spare in case the primary fails. Good thinking. Ideally, the backup would have the same version of pfSense and its packages, but how do I accomplish this? Doing a backup of the config XML file on the primary and restoring it to the backup is easy enough, but it seems the backup box needs to be connected to the internet to get updates of pfSense and its packages. I could temporarily replace the primary with a backup to update pfSense and packages, but this seems a bit cumbersome. Can you suggest an easier way? So should that be a cold standby or a hot standby? Or just any kind of standby to just have a way to switch without losing much time or data even?
Yeah, so the way I've done things like this normally is each of these two boxes would have their own IP address, and then they would have one that they shared with something like CARP, where only one of them would be active at a time. And that way, the backup could still be on the internet and download stuff, but if the primary goes down, it would then take over both the public-facing IP and the internal-facing IP, so that all the clients would connect to them. It depends how you do this. Like, I don't know if pfSense has something for this, but there's a process called pfSync, which actually syncs the firewall state. So like the NAT rules and the actual like open connection state between the two machines, so that when you do fail over to the other one, any open connections you have don't get dropped as well. And so you might want to look more into something like that. But yeah, if you're just trying to back up and restore the config, then it's going to want the same IP addresses, and it's going to make a bit of a mess. Yeah, I don't know a great answer off the top of my head to that, other than, having it configured as a regular client and getting the updates, and then only restoring the config file when you actually need to flip the switch, or looking into something more complicated like the active setup I was discussing, where both of them would be on all the time, and the failover might even be automatic, where you can just pull the plug on the first router and the second one would automatically detect that within milliseconds and switch over.
Yeah, if other people have done things like that or have a cool setup somewhere, then definitely send this to us and we will follow up on this one. And then everyone knows about this and we'll have a proper backup, because that's what we want to have, right? Primary goes down, secondary is available, and vice versa. You can switch back after the primary is back up again.
Yeah, and it's basically what CARP and pfSync were designed for. But I don't know if pfSense really offers an out-of-box solution for that, because it gets much more complicated when you want to have active like that.
Yeah, hope that gave you a couple pointers to get this done. And definitely let us know if it solved your question, or if you maybe have time to write a blog post or something, then other people can also get that knowledge. From Carl to Val, the second one is the second question, ESXi question. Sounds interesting. Val writes, "Hi Benedict and Alan. I have been a FreeBSD user and fan for over 6 years now. Many of my reasons why can be attributed to this great podcast." Ah, great.
Cool.
I run a small home network. At the heart of it's a Dell T110 running VMware ESXi. The VMware server hosts the following VMs, all running FreeBSD. VM1, pfSense VM acting as my home router firewall. VM2, Plex server. VM3, remote access server I use to SSH into my network remotely and create tunnels. VM4 is a utility server that runs various tools such as transmission, sonar, and an OpenVPN client. So far, so good. The ESXi server has 3 physical NICs. 2 of the NICs are bonded into a static port channel configuration as a trunk to a Cisco 3560 switch. The 3rd NIC is plugged straight into the ISP modem as an access port. On the ESXi server, the port channel is tagging packets for various VLANs, public Wi-Fi, streaming devices, servers, etc., into separate vSwitches, which are in turn fed to the pfSense VM as a separate virtual interface, while the 3rd NIC is handed directly to the pfSense VM to grab a public IP directory from my modem. The other 2 VMs are nothing special. Okay, so for the most part, this setup works perfectly fine. However, I have been looking at replacing the Dell server with a more modern, capable hardware to follow me to host more VMs. Extend. Also, as comfortable as am I administering the ESXi server, I have been playing a bit with Beehive on a physical FreeBSD test machine and have found it fairly easy to build and manage VMs using IOHive. I would also like to be able to snapshot these VMs using ZFS and back up those snapshots to my FreeNAS Mini. All good thinking. So here are my questions. Do you believe Beehive is stable and mature enough to be run in a production environment and capable of replacing VMware ESXi?
So Beehive is stable enough to be run in a production environment, and plenty of people do. For replacing ESXi, it mostly comes down to the management bits. If you're just using VMware to start the VMs and leave them running, then yes, Beehive can do that. But if you're doing more complicated things and are trying to, if your configuration changes frequently, you might find Beehive that the tooling around it is not as mature yet. But as far as, running 4 VMs and keeping them running, Beehive will do fine.
Yeah, if you're comfortable on the console, then that's fine. If you're more the GUI or web type person that configures everything, that's a bit not present in Beehive, because that's not the development goal of Beehive necessarily. So ESXi has the better GUI in this department.
Well, it also took VMware 15 years to get to ESX to be something that usable.
Oh yes, they have a lot of a head start, and Beehive is quick to catch up, but not as quick. So, but definitely production ready, and a lot of people are using that in similar environments. Second question is it possible to easily duplicate my setup in Beehive, specifically my pfSense config?
Yes-ish. Basically, those vSwitches will be replaced with bridges, and you'll do it that way. Then mostly you'll have to decide one way or the other whether to do the VLAN tagging on the host or in the VM. But since they're all controlled by you, you can just do whatever's easier. Obviously, if it's an environment where you don't control the contents of the VM or don't trust the contents of the VM, you'd want to enforce the VLANs on the host side. But yes, basically you would take your physical NICs and then apply the VLANs to them, which basically creates a new interface like, IGB 0.100 for VLAN 100. And then you would create bridges for each of those vSwitches and put the VLAN into it, and then the tap interfaces that come from the Beehives into the right vSwitches or bridges. And then, and then you could choose to do the full PCI pass-through thing to get the NIC that goes out to the modem directly into the pfSense, or you can just do it as another vSwitch, a bridge of the tap in that physical interface.
Then the third, is IOHive your recommended method of managing or creating virtual machines for Beehive, or could you offer a better, easier solution to manage these VMs?
I don't have much experience with any of the Beehive tools. I've mostly done it the manual way because of my needs are usually for temporary VMs to test stuff that I've just built and doing NFS root VMs so that I can recompile the kernel on my 40-core machine and then boot it in a VM and see if it works, and then see it not work, and then make a change and compile again and then boot the VM again, and it automatically picks up the new kernel. More advanced things, but as far as I know, IOHive is okay. I know that I think IO Cage has some stuff now or something. I don't know.
That's what I use.
There are lots to pick from. I don't know if anyone is better than any other one. You might have to ask people that use one of the other tools.
Yeah, I use IO Cage heavily. I would say, well, you know how VMs are like, if they're running, everything is fine. You don't need to manage them all the time. And just to create a couple of them, they get the job done pretty quickly with IO Cage Create. I think bhyve is also quite capable of solving that problem. And the management layer is probably similar to the other one. Okay, and then what are your thoughts on running FreeBSD on bare metal systems using AMD Opteron CPUs? The new server I'm looking to purchase is an HPE microserver Gen 10 that features this type of CPU.
Probably fine. Like, I know that Beehive worked on some of the AMDs. I don't know for sure how great it is on later ones, but I think it's supported. It sounds like the microserver Gen 10 uses an APU, which is AMD's kind of smaller CPUs. I can't give you an exact opinion on that, but you might check the Beehive mailing list. But as far as I know, Beehive works on the older Opteron type AMDs and the newer Ryzen type.
Yeah, maybe you can find a D-message for that exact CPU in a system that's booting. And
well, I don't know that that actually helps you know how well Beehive is supported. If you're not trying to do PCI pass-through, I think most of it is probably working, and I don't know for sure on the hardware pass-through for AMD specifically.
Yeah, hunt around a bit on the web. Maybe there's someone who has that already.
But yes, these microservers are extremely popular for FreeBSD, and I'm sure somebody has tried Beehive on it and has posted the results somewhere.
If you want, you could document your journey, like, for example, Dan Langell does in all his doings, everything that works, everything that is not working yet with some error messages maybe. Would be nice to have this kind of setup that you're trying or replicating as a series of blog posts, for example, so we can either feature here on the show, or other people could also be interested in a similar setup and make use of your knowledge written down this way. Definitely keep us informed if you have something new there. The next person is Lars with an OpenBSD router hardware question. So this is a bit shorter, but nonetheless important. Goes like this. Hi, JT, Alan, and Benedict. Happy midsummer. Thank you. Happy midsummer to you as well. Which hardware would have 8 to 12 port gigabit Ethernet and be capable of running OpenBSD? This would need to be available in Europe. Bonus for non-x86 systems. If one can dream, it would be very nice to have GPIO pins as well. But the essential characteristic would be gigabit Ethernet for all 8 to 12 ports.
So it can depend a bit on what you're actually after. There are some hardware which will have an 8 or 12 port switch, where there's another port in that switch that goes into the CPU in the hardware. And the advantage of this is obviously it means you don't have to go through the CPU at all when you want traffic to come in one of those 8 or 12 ports and go out another one of them. But that, if the traffic is pointed at the router, it can actually come in. But, in that type of situation, often the bandwidth into the router, or the bandwidth that's actually going to pass through the router, is going to be limited to the 1 gigabit on it, because it's actually basically a 9th or 13th port in the switch. Or something more like, a regular machine with 3 quad port NICs that are PCIe cards or whatever, that can give you that, and maybe be more capable of getting bandwidth in and out of the CPU. It kind of depends what you're wanting it for. For a router, yeah, it basically depends. Do you actually want a switch that is also a router, or do you want just a router where you actually need to be able to, have traffic come in on a bunch of these ports and then go out different ports depending on what's happening? So I guess the good question, if this is a router and it's got 8 or 12 gigabit ports coming in, do you expect the destination of all this routing to actually be just one port at 1 gigabit? Then it maybe is easier to do with something like that. Like the little MIPS TP-Link router that we did at BSDCan a couple years ago was 6 or 8 port switch and then the CPU was on one of those internal ports I kind of mentioned. And there's even a FreeBSD tool called switchctl that you can use to configure the VLANs and stuff that apply to each of those ports. And, it's meant to be a Wi-Fi router, basically. But, we've kind of overloaded the word router in that case, right? Yeah, if it's just meant to be a gateway where it's going to do NAT for these 8 or 12 ports out a single gigabit port to the internet, then you probably want more of the switch type. Whereas if it's actually going to, take internet in on 8, or, take traffic from machines in on 8 of these ports, and then the next 4 ports are going to 4 different destinations, and the router is actually going to route traffic and make decisions more than just, firewall and NAT, then you probably need something that actually has 12 separate gigabit interfaces rather than basically an 8 or 12 port switch with a tap that goes to the CPU of the gateway machine.
Mm-hmm.
I've not really looked for this type of hardware before. I think there's a Supermicro chassis that has something like this, and then the PC Engines makes a lot of things like this, although I don't know that they go up to 12 ports for that.
Yeah, check out the website. There's probably more. Maybe if one of our listeners has exactly this dream port or gigabit Ethernet device, then definitely reach out and we'll do a follow-up on this one. And then maybe other people who are also desperately looking for exactly this kind of hardware will know it from a future episode.
But yeah, so I know Supermicro makes some stuff now that's even designed to be mounted on a telephone pole or a telegraph pole.
Ooh, okay.
But they have some things that have 8 gigabit ports and then some SFP slots for faster than that. Like the random one I just clicked on, this one's probably much bigger than what you're actually looking for, but dual power supplies, 4 2.5-inch drives, 9 gigabit interfaces, plus 4 10 gigabit interfaces, and then a dedicated IPMI slot or a port, and a beefy 14-core Xeon D processor.
Yeah, okay. That's beefy.
And room for a bunch of expansion cards, so you can do other stuff with it. But yeah, so that such things do exist, although it really depends on your use case, whether you want something that actually has 8 of those gigabit ports, or if you actually just want something that has an 8-port switch with a 1 gigabit tap to the router or whatever.
Okay, so far so good. Maybe you can find that little gem that we haven't found yet.
Hopefully with that in mind, you'll be able to have a more productive search. And whether you're actually looking for something that has a switch that is connected internally to the motherboard, so that you can if you're just after making a little NAT gateway, that's probably what you want. Whereas if you're doing something slightly more heavy duty, where you might actually want 8 separate gigabit ports.
Yeah, that pretty much wraps up this week's episode. Thank you for listening, as always. Keep us posted of anything that is in the BSD space that we might not have picked up on our radar, and let us know on feedback@bsdnow.tv. And then next week, of course, there's a new episode for you fresh out of the oven. Well, looking at the temperatures outside, that's more oven-like. Thank you for listening, and till next time.